Sometimes a sketch in FreeCAD just refuses to move. A corner is dragged, a line is pulled, and it sits there like it's welded to the screen, while Solver up top quietly screams, redundant or over-constrained. This episode goes full constraint detective. It hunts down which rule is handcuffing which piece of geometry, treats the tasks panel like a control room, and coaxes that stubborn sketch back into something that actually responds. By the end, random constraint deletion and desperate clicking are off the table. There's a calm, nerdy little playbook for taming won't-move sketches whenever they sneak into a FreeCAD project. This is Nerding Out with Nevin, and this episode lives inside the FreeCAD Made Easy series, an ongoing quest line that runs from first sketch all the way to confident 3D builds, with a playlist waiting below once this chapter is done. Brand new FreeCAD explorers may want to begin at part 1 of the FreeCAD Made Easy series. So this episode lands as a fun puzzle rather than a fire hose. If you enjoy this or any other Nerding Out with Nevin video, and you appreciate a good nerdy deep dive into FreeCAD, do me a quick favor and tap that like button. It really helps the channel grow. To catch future FreeCAD Made Easy episodes, hit subscribe and tap the bell so YouTube actually tells you when the next one drops. All right, let's get to it. The starting point is the square with a circle block from part 2, from 2D shapes to 3D models, reused in part 3, Pocket Tool, already padded into a simple 3D shape. Both the pad and the sketch are visible at once, which works for modeling but is a bit noisy for constraint detective work. The sketch is activated from the model tree with a double click, dropping straight into Sketcher edit mode. The focus then shifts to the Tasks tab, where Solver messages, the Constraints list, and the Elements list live together like a little control room for everything that happens in this sketch. To get a clean crime scene, the solid is temporarily hidden. The pad is selected in the model tree and its eye icon is toggled, or the spacebar is tapped to switch off visibility. What remains is just the 2D sketch floating on its own. This becomes the standard debugging habit. Hide the solid and investigate the bare sketch whenever geometry refuses to move. The Sketcher Tasks panel is stacked top to bottom. Solver messages at the top, the Constraints list in the middle, and the Elements panel at the bottom. Constraints are the rules. Elements are the geometry. 1 line, 2 line, 3 line, 4 circle, 5 line, and friends. Checkboxes flip visibility on and off. And the filters drop down keeps the clutter low. With the sketch active and the pad tucked out of sight, the Sketcher Tasks panel becomes our mission control. Top to bottom, it tells the tale. Solver, Constraints, then Elements below. First, what's wrong, then which rules, then which bits of geometry glow. It's FreeCAD narrating the mystery of why won't this thing move, line by line. At the very top, the Solver messages set the mood. If everything's happy, you're fully constrained and feeling good. If not, you'll see under-constrained, redundant, or over-constrained instead. Anytime your sketch locks up, this is the first line you should read. It tells you what kind of gremlin you're chasing before you poke a single edge. In the middle lives the Constraints panel, the rule book of the realm. Coincidences, horizontals, verticals, equal lengths at the helm, dimensions, radii, and more. Each row a tiny law with its icon and value. When you really need to take a constraint out of play, the context menu in that middle list has a deactivate option waiting for that specific rule. It's a safe way to experiment with the sketch's logic without deleting anything. At the bottom is the Elements panel, the cast list of the sketch. 1 line, 2 line, 3 line, 4 circle, 5 line, and every shape you fetch. Click a line or circle on the canvas and its row lights up down here. Click a row in the list and that element highlights in the sketch, nice and clear, with its constraints glowing in the middle panel like loyal sidekicks. This whole bottom panel setup keeps monster sketches from turning into chaos, giving you a warp speed jump to that one line, even in a crowded scene. Light theory, degrees of freedom, and stuck geometry. Think of the degrees of freedom counter as the sketch's tiny heartbeat, ticking down with every rule you apply. Each constraint closes a door, removes a wiggle, and shuts down one more sneaky escape route. When the solver throws shade with redundant or over-constrained, it usually means we have stacked too many laws on one poor piece of geometry. Back in parts 2 and 3, we met degrees of freedom, so here is the quick refresher. A newborn sketch is pure chaos, lines drifting, angles wandering, circles exploring wherever they please. Each constraint you add tames a bit of that chaos, removing one axis of mischief, while the degrees of freedom counter keeps score as the sketch settles into order. When the counter finally drops to 0 and the solver whispers, fully constrained, the sketch is not stuck because it is broken. It is stuck because it knows exactly what it is, ready to update cleanly whenever you change a dimension. Trouble begins when that column flips. Fully constrained becomes redundant or over-constrained, and suddenly nothing moves the way you expect. Drag a line and something else mocks up. Tweak a dimension and another corner rebels. Usually because one piece of geometry is overloaded with rules, or two constraints are quietly arguing over the same job. Hidden conflicts often sit silently until you try to make a change, and that is when the sketch fights back. FreeCAD tries to help by adding automatic constraints as you draw, usually a blessing that saves time. But some of those automatic rules become stealthy tripwires that block motion later, turning extra constraints you never intended into co-conspirators in redundancy. So as we debug, remember, every constraint removes motion. A fully defined sketch is healthy, and any warnings, strange lockups, or odd reactions to editing a dimension are clues that one piece of geometry has more rules than it needs. Our mission is to find those extra rules, clean up the duplicates, and restore the sketch's balance. The sketch opens in a well-behaved mood, nothing selected, and solver calmly reporting fully constrained. For a finished profile, that is the ideal status line. Every segment and circle is parked in its assigned spot. No road degrees of freedom drifting around the grid looking for trouble. Then the design brief shifts, and the middle horizontal line becomes the new variable in the experiment, the slider that is meant to reshape the block and quietly kick off the real detective work beneath the sketch. At this point, the path forks. One route simply deletes the stubborn line and redraws it, while the other takes a slower, more thoughtful pass to uncover the exact rule that refuses to let the line move. In this sketch, that middle line already carries several constraints, each one tying it to the surrounding geometry. Deleting the line would not only erase the segment, but also tear out those relationships, making a simple redraw much less attractive than tracking down the actual culprit. The investigation begins in the constraints list, stepping through one entry at a time as each rule takes its turn under the spotlight. On the canvas, the matching constraint symbol flickers to life in its true location, a tiny beacon sitting on the very geometry it controls. Watching where each icon appears and which corners or edges it quietly anchors turns the sketch into a little map of relationships. When the symmetry symbol lights up along the middle horizontal edge and the vertical reference, the real culprit reveals itself. A single rule standing guard and refusing to let that line move. Earlier, those checkboxes beside constraints and elements were introduced as simple visibility switches. In constraint debugging, the same switches become a tiny lab bench. Hide one constraint, note which symbol disappears from the sketch, then restore it once the association is clear. The control is identical, but now it is being used as a probe rather than just a display toggle. After repeated checks point to the same suspect, the context menu becomes the next tool in the chain. The implicated constraint is deactivated first, giving the sketch a moment to breathe without that rule in play. A quick drag on the line becomes the test. If the geometry shifts as intended, that constraint stands confirmed as the culprit and can be deleted with confidence. With that symmetry constraint removed, the middle horizontal line is no longer locked to that reference and can slide freely as the design requires. While the hunt is underway, the Elements panel can tag along as a quiet sidekick. It is not required to solve this particular constraint puzzle, but in larger sketches it doubles as a handy lookup table for which line is which. Selecting the middle horizontal edge in the sketch highlights that segment and lights up its matching row in the Elements list. In one step, a mystery line on screen turns into a clear label like 3-line in the task panel. That mapping becomes especially helpful once sketches grow dense, with edges and arcs crowded together like a small galaxy of construction lines and references. Pairing this glowing line on the canvas with this numbered row in Elements keeps navigation sharp and constraint debugging grounded in specific geometry. The sketch returns to a clean, orderly state. Everything snapped back exactly where it was before. Solver reports, fully constrained, every edge holding position with zero drama. A second symmetry constraint is then added, again involving that same middle horizontal line and the right-hand vertical. The moment that new symmetry locks in, Solver jumps to redundant constraints and the entire sketch flashes red, a full-screen warning flare. Solver now lists two specific troublemakers, Constraint 9 with the symmetry icon and Constraint 10 with the horizontal icon. Both sit on the same middle horizontal line, both trying to keep that span perfectly aligned, and together they create one equation too many in that tiny patch of geometry. Mathematically, the new symmetry in Constraint 9 already guarantees that the endpoints stay at the same height. That means the extra horizontal rule in Constraint 10 no longer brings any new information. The system is fully defined either way, and that duplicated job appears as a redundancy warning. In this demo, the fix is to take Solver at its word and clear out the entire knot. Both Constraint 9 and Constraint 10 are removed, dropping the extra symmetry and the extra horizontal in one move. The warning in the Solver bar vanishes. The sketch stays visually identical thanks to the remaining constraints, and the equation system snaps back to a clean, correctly constrained state. In a real project, the move is just as simple. When redundant constraints lights up and Solver points straight at a pair like Constraint 9 and Constraint 10, remove the overlapping rules that no longer match your design intent. Or tap Undo on the main toolbar or Ctrl+Z on the keyboard to roll the sketch back to just before that second symmetry went in. The next task is to push that middle horizontal line all the way over to the green y-axis. At the moment, the left end of the line is locked to the left construction line, so any attempt to stretch the line or edit its length just stalls. A constraint on that shared corner is still gluing the endpoint to the left wall. The goal is to find exactly which constraint is responsible without disturbing the symmetry that keeps the circle centered between the top and bottom of the little box. To track it down, the hunt starts in the constraints list and works back toward the geometry. The left end of the horizontal line shares a point with the left construction line, and that kind of relationship is usually a coincidence constraint. That narrows the search to the rows with the coincidence icon, which are clipped one by one instead of poking at everything. A coincidence constraint is used to connect a point to a line. With this in mind, the search can be sped up by filtering on Point on Object. This narrows the list, showing only what needs to be looked at. Each time one of these constraints is selected, its icon flickers on the sketch. The mouse wheel zooms in, and the middle mouse drag pans to bring that symbol to the center of the view. After a few passes, it becomes clear which icon belongs to the circle's symmetry pair, and which one is the simple coincidence that ties the left end of the horizontal line to the left construction line. Once the specific coincidence holding the horizontal line to the left wall is identified, that constraint is right-clicked in the list and deactivated, leaving the circle's symmetry constraint untouched. Now the middle horizontal line can be extended to the y-axis, and a new coincidence created between the line's left endpoint and the vertical axis. The circle stays perfectly centered between the top and bottom because its symmetry constraint still stands, but the line is now anchored to the y-axis instead of the old construction line. This is the constraints geometry habit in motion. Start from the rule in the list, narrow the search by constraint type, click it, zoom and pan to see where it lives on the sketch, and then adjust only the one constraint that is actually blocking the change. The story began with the classic won't move sketch. A line is dragged and simply refuses to go anywhere, while Solver complains about being redundant or over-constrained. The mission was to stop guessing, stop randomly deleting constraints or geometry, and instead learn to find the one rule on the one piece of geometry that is actually causing the problem. The core habits are simple. Hide the pad so only the 2D sketch remains, read the tasks panel from top to bottom, and pay attention to what Solver and degrees of freedom are reporting. Fully constrained is the good kind of stuck, and warnings about redundancy or over-constraining usually mean one corner, edge, or circle carries more rules than it truly needs, often thanks to auto-constraints lending a heavy hand. From there, all of the detective work runs through the constraints list. Read what Solver is complaining about, then walk the list one entry at a time, watching where each constraint's icon appears on the canvas. Use the visibility checkboxes to hide and show constraints so the symbols that disappear and the ones that remain tell their own small story. This is the constraints geometry path in action. Add a redundant symmetry or track down the coincident constraint gluing the line to the left wall. Click the constraint in the list to make its icon appear on the canvas. Zoom and pan until it comes into view, and then deactivate or delete only the rule that is actually blocking the change that needs to happen. If any won't move sketches appear in day-to-day work, or any other FreeCAD issue crops up, a comment describing what Solver is reporting and which constraints are involved can turn that puzzle into a future episode. Those real-world cases help shape which tricks and detective patterns are worth exploring next. Anyone who wants to see how this sketch was built from scratch can jump back to part 2 of FreeCAD Made Easy, which walks through the original square and circle profile and turns it into a 3D pad. For deeper constraint practice, part 3 dives into the pocket tool and shows how constraints drive that cut. Subscribing to Nerding Out with Nevin, leaving a like, and adding questions or ideas in the comments all help keep FreeCAD Made Easy growing. And they keep this kind of constraint detective work flowing from first sketch to confident editable 3D models. Thank you for watching.